Hello viewers, today we are solving some physics questions under moment of inertia. So our first question that we have says an airplane propeller has a mass of 60 kg and a radius of gyration of 75 centimeters. Find the moment of inertia. That's part 1. Then part 2 says we have to find the torque if the angular acceleration is 4.0 rad per second squared. So first we need to collect our data. That's the first thing that we do. So we need to collect our data. Okay, so we have an airplane propeller that has a mass of 70 kg. So the mass of the airplane propeller is 70 kg, and the radius of gyration is 75 centimeters. 75 centimeters. That's what we have. So to find the moment of inertia, that is part 1, we say moment of inertia is equal to mass times radius squared there. So the moment of inertia will be the mass that we have is 70 kg. So you substitute with units. Then the radius, we use the radius in meters. So since the radius that has been given, it is in centimeters, so we need to convert this one to meters. So now the way we convert, we know that in 1 meter we have 100 centimeters there. So here centimeters and centimeters cancels, so we divide 75 divide by 100, it gives 0.75 meters. So now we substitute with the radius in meters that we have converted, so times the radius, which is 0.75, that is meters. Now remember to square that because the radius is squared whenever we're finding the moment of inertia. So the moment of inertia will be equal to, so we multiply, we say 70 times 0.75, this should be squared. So I'm getting the moment of inertia of 39 point, that is for the units are kg meter square. So this one becomes the moment of inertia for part 1. Then part 2 is asking us to find the torque if the angular acceleration is 4.0 rad per second squared. So if given that we have found the moment of inertia and we are given the angular acceleration, that is for part 2, okay, so the angular acceleration that we have been given, it is 4.0, that is rad per second squared. So given the angular acceleration and also given that we know the moment of inertia, we can find the torque. So we say torque is equal to the moment of inertia times the angular acceleration. So you're just multiplying the moment of inertia in the angular acceleration. Okay, so now torque here will be equal to the moment of inertia that we found on part 1 is 39.4, then that is kg, then meter square. Then we multiply this with the angular acceleration, which is 4.0, that is rad per second squared. So torque becomes, so we just multiply, that is 39.4. Then we multiply this one with a 4. So I'm getting 157.6. Then the units for torque, we use Newton meter. So these are the units that we use. Then we have our second question, which says find the moment of inertia for the system in the figure below. Okay, so we have a diagram here. We have 4 pins. So we have pin 1, pin 2, pin 3, and pin 4. Okay, all these, they have their own mass. Okay, and what we can see from this our diagram is pin 1 has a mass of 0.2 kg, then pin 2 a mass of 0.3 kg, pin 3 a mass of 0.20 kg, and also pin 4 has a mass of 0.30 kgs. Okay, So we have 4 pins. And also when we look at the radius that has been given here in our diagram, we can see that the distance from the center to where pin 2 is 0.50 meters. That's the radius. So this means that on this our diagram that we have on this our system, the radius is the same. Okay, that is the distance from the center to where the pin is. The radius is 0.50 meters for pin 1, 2, 3 and 4. The radius is the same, which is 0.50 meters. So now to find the moment of inertia, there are different ways in which we can find the moment of inertia. One of the way is, we'll say the moment of inertia, it is just equal to that is the summation of the mass times radius squared. This is the general formula that we use for the moment of inertia. Then now what we'll do is we'll say the moment of inertia will be equal to, since on our diagram we can see that pin 1 and pin 3, these 2 pins, they have the same mass, which is 0.20 kg. So what we'll do is we'll say 2 times their moment of inertia. So I'll take the mass for pin 1 and 3 to be small letter m, then radius squared. Then we'll also add the moment of inertia for pin 2 and 4. Since pin 2 and 4, they have the same mass, so we'll add. So we'll take the mass for pin 2 and 4 to be capital M. Since you have 2 pins that have the same mass, so we also say 2. Then now we'll change the symbol for the mass to be capital M, since the mass for pin 2 and 4 is greater than for 1 and 3. Okay, then we say radius squared. So now we just have to substitute. So the moment of inertia will be 2, then we multiply by the mass. So the mass is 0.2, okay, 0, that is kg. Then we multiply this by the radius, which is 0.5, that is meters. Then don't forget to square this. Then plus, we have 2, then times the mass of pin 2 and 4 is 0.30, that is kgs. The radius is 0.5, that is meters. Then we need to square this. So now the moment of inertia gives, so we need to multiply. Right, so when I punch on my calculator, I'm getting 0.25. We know the units are kg, then meter square. So this one becomes the moment of inertia for this our system. Then the other way in which we can find the moment of inertia as well, we can also say, since the radius is the same for pin 1, 2, 3 and 4, so what we'll do, say the moment of inertia should be equal to, now since the radius is the same, so you first add all the masses, the mass for pin 1, pin 2, 3 and 4, so you add them. Okay, so pin 1 has a mass of that is 0.20 kg. Then pin 2, as you can see, so we are adding the masses. Pin 2 has a mass of 0.30 kg, as you can see. Then pin 3 has a mass of 0.20 kg. Then pin 4 has a mass of 0.30 kgs. Okay, so you add the masses. Then after adding, now you multiply by the radius, which is 0.5, that is meters. Then don't forget to square the radius. So the moment of inertia becomes, so first we add all the masses, so 0.2 plus 0.30 plus 0.20, then plus 0.30, so it gives 1 kg. Then we multiply this by the radius, which is 0.5 meters. Then don't forget to square the radius. So the moment of inertia becomes, so we multiply 1 by 0.5 squared. So this gives 0.25, then kg, then we have meters squared. So you see, we are getting the same answer. Or you can also find the moment of inertia for each pin, then you add. So we say the moment of inertia is, we say the moment of inertia for the first pin it to be its mass 0.20, okay, that is kg. Then we multiply it with the radius, which is 0.5, that is meters. Then this should be squared, okay. Then we also move to the second pin, which has the mass of 0.30 kg. Then the radius is the radius is 0.5, that is meters. Then this should be squared. Then we add the moment of inertia now for the second pin, which is 0.20 kgs. Then we multiply by the radius, which is 0.5, that is meters. Then this should be squared. Then plus the fourth pin, which has the mass of 0.30 kg. Then we multiply by its radius 0.5, that is meters. This should be squared. So we still get the same answer, which is 0.25, that is kg, then meter square. So that becomes the answer.